Hello dear students, welcome back to my science class. Today I am going to continue with the chapter 9, Soil. In our previous two videos, we have already discussed about utility of soil, soil profile, composition of soil, different types of soil, and also we have started discussing about properties of soil. Today, we will continue our discussion with properties of soil. In our previous video, we have discussed about one property of soil, that is percolation rate of water in soil. There we have seen that rate of percolation of water is maximum in sandy soil, intermediate in loamy soil, and least in clay soil. Today, we are going to discuss some more properties of soil. So, let's start. Moisture in soil. Have you ever passed through a farmland during a hot summer day? Perhaps you noticed that the air above the land is shimmering. Why is it so? Try out this activity and find the answer. What we are doing in this activity? We have taken a boiling tube, right? We have taken a boiling tube and we have fixed it on a stand. We have taken some soil sample and heating it using the burner. What we will see after some time, we will see droplets of water on the boiling tube. Can you tell me what is the reason? Yes, you guessed it right. The reason is the soil contains moisture in it. On heating, this moistures get evaporated and they are getting cool surface on the upper part of the boiling tube. And so this vapor is condensed to form water droplets. So if we heat soil sample, taking it in a boiling tube, after heating it, we will see droplets of water in the boiling tube. That confirms that yes, soil sample contain moisture in it. On heating, water in the soil evaporates, moves up and condenses the cool inner wall of the upper part of the boiling tube, what is just explained to you. On a hot summer day, the vapor coming out of the soil reflects the sunlight. And the air above the soil seems to shimmer. After heating the soil, take it out of the tube, compare it with the soil which has not been heated. Note the difference between two. You will see distinct difference in the texture between the soil. The same soil actually. We have taken same soil and we have kept some soil, that is we have not heated, and some amount of soil we have heated. You will see distinct difference between the two soil after one part is heated. Next property of soil, that is absorption of water by the soil. This is very important property. Do all the soils absorb water to the same extent? Let us find out. Take a plastic funnel. Take a filter paper or a piece of newspaper sheet. Fold and place it as shown in figure 9.7. We will see to it. Weigh 50 grams of dry powdered soil and pour it into the funnel. Measure a certain amount of water in a measuring cylinder and pour it drop by drop on the soil. You can use a dropper for this purpose. Do not let all the water fall at one spot. Pour water all over the soil. Keep pouring water till it starts dripping. So, this is how we are going to do the experiment. We have taken a beaker. right? We have fixed a funnel on it. We have fixed a funnel on it. We have set a filter paper on the funnel, right? Then we have taken some soil and we have kept the soil. We have weighed. The amount of soil is 50 grams. We have kept the soil into the filter paper. Now we have taken some amount of soil, say 100 ml, right? Now, drop by drop, we are pouring that water all over the filter paper so that we can weight the entire soil that is poured inside the filter paper. We will wait until it started. Drop by drop water is falling down through the filter paper. So you have to understand that water will start dropping when it will exceed the limit of water retention of that particular soil. That means up to what it can retain the water, it will absorb water. When it will not be able to retain the water, water will started coming out of the funnel as drops. So, one thing is very clear from there, where we can see more water into the beaker. That means water retention capacity of that soil is less. I hope your understanding is clear. If the water retention capacity is more, the soil will absorb more water, and least amount of soil we will observe that is fallen down on the beaker, right? So which is maximum water retention capacity, in that beaker we will get less amount of water. Okay. Now how to calculate, right? We have taken 50 grams of soil. So subtract the amount of water left in the measuring cylinder from the amount of water you started with. This is the amount of water retained by soil. Record your result in your notebook in the following manner. Okay. What we are doing? Already we have taken 50 grams of soil. So weight of the soil is 50 grams. Initial volume of water in measuring cylinder is UML. Suppose I am telling you that the initial volume of water is 200 ml. Okay. Final volume of water in the measuring cylinder is VML. Suppose we are taking that in measuring cylinder we have only 100 ml left when it started dropping. So the volume of water absorbed by the soil is U minus VML. We had 200 ml of water, and when 100 ml is absorbed by the soil and it started dropping, we have 100 ml of water in the measuring cylinder, right? So U minus V, we are subtracting those two amounts. Weight of water absorbed by the soil is U minus V gram. That is the volume and this is the weight. 1 ml of water is equal to 1 gram. That is why we have just converted ml, milliliter into gram. So, percentage of water absorbed. U minus V is the 50 gram of soil absorbed. So, 1 gram soil is absorbing U minus V by 50 and percentage is U minus V into 100. So, percentage of water absorbed we can get using this formula U minus V by 100. Okay. I will again repeat it for you so that it can make your understanding clear. We have taken 50 gram of soil, right? Suppose here we have taken 50 gram of soil. Now I have 200 ml of water in a container. I am taking there and I have started drop by drop falling the water over the soil. When I have 100 ml of water left in my container, I will see that drop by drop water coming out from this funnel. That means 100 ml of water is absorbed by 50 gram of soil. So 1 gram of soil has absorbed 100 by 50. So what is the percentage? 100 by 50 into 100. That percentage of water is absorbed by the soil. And obviously, if we do with different type of soil, if we keep here sandy soil, loamy soil, clay soil, in all the cases, we will get different result. That means percentage of water absorbed will definitely vary. Repeat this activity with different soil sample. Would you get the same result for all the sample? I have told you definitely not. Discuss the result with your friends and answer the following question. Which soil would have highest percolation rate? As expected, highest percolation rate will be of sandy soil because the particle size is bigger, gap is bigger. Which soil would have lowest percolation rate? Clay soil. Bozo heard from his neighbor that 8 to 10 days after the rain, the level of water in a pond or well rises. Which type of soil will allow water to reach a well faster and in greater amount? Which type of soil retains the highest amount of water which retains the least? Highest amount of water retention capacity we can observe in clay soil, and least water retention capacity is obviously in the sandy soil. Can you suggest any method to let more rainwater percolate and reach the water ground? So you have to suggest some method as that it is act like a sieve and let the rainwater percolate and reach the ground. So throughout this we have learned different characteristics, property of soil. Sandy soil, it is well aerated because there are particle sizes bigger, gaps are more, well aerated. So they cannot retain water. That is why we are not able to give them any kind of shape. And their water percolation rate is more, water absorption rate is least. And loamy soil have everything intermediate. The particle size are intermediate, half amount of bigger particles and half amount of finer particles. Water air capacity intermediate, water retention capacity intermediate. And clay soil is finer particles, so water retention capacity is highest. Do not let the water percolate faster. So we are able to make toys and different type of thing with that clay soil. So depending upon their properties, different types of crops are grown in different kind of soil. That we are going to discuss in our next class. Till then, thank you.